try to demonstrate this project here, cracking AES with weak keys. So we're going to run cryptool. We're going to use the wizard. You have to be on Windows. This cryptool only runs on Windows. Cryptanalysis, modern, symmetric. Let me see if I can do that. The wand. Cryptanalysis. Next. Modern. Next. And symmetric AES ciphertext only. All right, let's see. Symmetric is good. AES is good. Ciphertext only is good. This is the case we talk about most often. We're going to try and crack it by knowing only the ciphertext. So here it gives you some ciphertext to analyze. And here's the key. And notice you can feed in a variety of keys here. Let me go back here and see. Okay, so most of the key is known. Only part of it is unknown here. That's the idea. Let me, I'll just use this. That'll work, right? So you see, the key is A1, B1, C1, 11111, and there's only 3 bytes that are not known. So as you know, 1 byte is 256 possibilities, 2 bytes is 65,000, 3 bytes is 16 million. 16 million is not an impossible number of bytes to try. Now there are different modes. You might want to decrypt it in electronic codebook mode or cipher block chaining or cipher feedback. Those are the modes available here. We didn't talk about cipher feedback, but it's another one of the modes. So I'm going to try electronic codebook. Let's just go next and see if we can decrypt that stuff. And what it's going to do is it's going to run a brute force attack on the unknown portion of the key. So there you go. It's trying various values of the key. See, it's filling in the last 3 bytes with random numbers and trying them all. And then it's creating all these things. And notice right there, with all ones, it's getting something readable. So that looks like that's obviously the answer. They should all be ones. But I guess it's going to try them all. It's only going to take 1 more minute. It's doing 100,000 keys per second. It's got 16 million to do. So it says it's only going to take about another 40 seconds to finish. So let's let it go. Looks like that time estimate is kind of noisy, but that's pretty common, especially on Windows-based systems. But it shouldn't be too much longer before it feels like it's tried every possible key. Now, an interesting issue is, if you try every possible key, they each give you junk. How do you know which one is readable? And in most cases, you can just see which one for all of them are readable characters. And that would do it. As I mentioned before, with the one-time pad, you would get every possible series of characters, including a whole bunch of readable ones that are wrong. But with most encryption schemes, including AES, you pretty much get garbage, except for the one that's right, which you can read. So it's pretty easy to pick out the good one when doing a brute force attack. It's done with the attack. So there should be an answer somewhere. Yep, and there's the answer. So the answer, as I said, is there should all be ones over here. And then you get some text, which is German, but at least it's readable, something about AES. So that's showing you how a brute force attack can go. All right. So that's the game. And so here's one to encrypt. And I tell you, it's in ECB mode, and the key is all zeros except the last 24 bits. The one we just did as a demonstration was 24 bits. The most common mistake students make is they had to make 6 bytes of unknown key, and that's an unthinkable huge number that will take forever. It's 8 bits for a byte and 2 hexadecimal characters for a byte. So this is one, and here's another one. The key is all F except the first 12 bits and the last 12 bits. So you have to figure out how to, and again, that's only 2 to the 24 combinations. So it'll only take a couple of minutes to try them all. And I say it might not be ECB mode. You might have to try a few. So there's just a few things to decrypt using that tool to give you a little practice. Of course, remember, AES is perfectly secure, as far as anybody knows, if they don't have information about the key. In this case, you have most of the key. You're only a few bytes of the key are missing, which is why you can do this. All right, good. That's what I wanted to show you there.